Hi everyone. How do we evaluate a function? How do we find a function output? So let's take this g of t rule from the previous example, and let's consider the values of g of 1, g of pi, g of 0, and g of negative 4. First of all, some of these will be real and defined outputs, and some of these will be non-real, and therefore undefined as outputs. Which ones? I'll give you a hint. Here's the domain that we obtained in the previous example. Is 1 in the domain of G? Well, 1's in this right interval, so yes, G of 1 is a real output. 1 is in the domain. What about G of pi? Well, yes, pi, again, is in the right interval here, so G of pi will be defined and real. But what about G of 0? 0 is not in the domain. We skip over the 0, so G of 0 is undefined. What about negative 4? G of negative 4. Well, negative 4 is not in the domain, is to the left of negative 3. So G of negative 4 will also be non-real and undefined. So of these four, G of 0 will be undefined, and G of negative 4 will be undefined. However, the others will be real and defined. We're going to get real outputs for these two. Now, if I ask you to evaluate G of 1 or G of pi, you may not have to find the domain first. It's often the first question we ask about a function, what's its domain? But bottom line is, if I give you a rule for G of t, and I ask you what G of 1 and G of pi are, usually what you would do is you would just plug in t equals 1 and see what happens. You'd plug in t equals pi and see what happens. For that matter, you could plug in 0 and negative 4, and again, you would see what happens. So for example, if you plug in 1 for t, we find that G of 1 simplifies to root 3 over 11, which is a real number. It's kind of ugly looking, but it's a real number. 1 is clearly in the domain. What about G of pi? We'll plug in pi for t over here. The result might be kind of ugly looking, but it's a real value. So pi is in the domain. We get a real output. But wait a minute. What if you try to plug in 0 for t? We'll see what happens. And it turns out you get a 0 denominator, which means right there you know, hey, G of 0 is not real, it's undefined. Or you could have found the domain at the outset, and you would realize that 0 is not the domain. Likewise, if you try to plug in negative 4 for t, the problem here is that we try to take the square root of a negative number, which is a no-no. Again, the result is not real, it's undefined as a real value. Or again, we could have found the domain, as we did here, and we observe that negative 4 is not in here. But if you're given g of t equals blah, 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 and you're asked to evaluate, instead of finding the domain explicitly at the outset, although theoretically we should, still, to evaluate these things, you plug in these values for t, and you see what happens. Do you have a problem with division by 0, or the even root of a negative number, or not? Again, 1 and pi are in the domain of G, so these values are defined as real numbers. 0 and negative 4 are not in the domain of G, so these are undefined as real numbers. Next up, a more complicated evaluation.